Alright, welcome to Earth Science. Time for sedimentary rocks. So, just like the other one, you're going to need your reference tables. This is on page 7. Page 7 of the reference tables up top, sedimentary rock identification. So let's talk quick about where these things come from. Going back to this old rock cycle note sheet that we've been using. There's two different kinds of sedimentary rocks we're going to have to look at. The first one I always feel like is kind of intuitive and obvious, especially since we've already done all the weathering and erosion and deposition stuff. And if you saw this morning's mini job, it was to go back and check out this reference table, reminding ourselves that we've got clay, silt, sand, pebbles, cobbles, boulders, from smallest sediment size to largest sediment size. So we've already gotten that down. Weathering makes sediments. It takes bedrock and it breaks it down. Erosion takes that sediment and transports it. And generally below water, though not always, but generally below water is going to be where deposition or drop-off takes place. And it takes place in layer upon layer upon layer. I mean, sediment lands, then more sediment lands on top of that, then more sediment lands on top of that, and so on and so on and so on. So where, I think that it's kind of intuitive is, you guys know what sand is. You've been to a beach, right? And if sand lands in a deposit somewhere and gets buried, if we go up here to the sedimentary table, it turns out that the grain size of sand makes this stuff called sandstone, lo and behold. Or the grain size of silt makes this stuff called siltstone. Clay, okay, they changed the name a little bit. Claystone's not a thing. It's called shale. We've got two other ones where if the other particle sizes, and these are mainly like mixtures, think glacial deposits if you remember that far back, these are like your mixtures, will make either conglomerate or breccia depending on whether the fragments are rounded or angular. Alright, so those, again I'm thinking obvious ones, are what we're going to refer to, and you're going to see this word, so circle it or circle it in your head, are what we refer to as clastic sedimentary rots. They'll even call sediments clasts sometimes. So sediment gets deposited and makes a sedimentary rock made out of sediment, right? No big deal. Now the one that's a little bit trickier to imagine is, let's do the same story. Let's say that there's weathering, erosion, and deposition, only let's do it with something that's soluble, if you remember that vocab word. It means it dissolves in water. And in fact, this was the reason why I set this experiment up a long time ago, back when you guys were all coming to my room every day. If you remember this, and I know this is like showing you a picture on the computer, it doesn't look great, but we made salt water as part of the lab, and then I stole some salt water from each of the groups, and it's just been sitting since then. Miss Peter went and took this picture for me this morning in my classroom. And what's happened is that the water has evaporated away. Now, this one formed like a skin over it, so the water stopped evaporating. But as like that much water has evaporated away, the salt has recrystallized. So that's still considered a sedimentary rock. I know it's like a little bit different, but in your head, if you can say, all right, if water washed over something that was soluble, that has the things that make up salt, like sodium and chloride as atoms. If you make salt water, or if you make Kool-Aid, sugar water, those atoms just go into solution. They're in there. They're in that water. There's sodiums and there's chlorides in that H2O. So go through that and then have that slightly salty water. All the rivers of the world have slightly salty water. The Salmon River going through Pulaski has slightly salty water out into Lake Ontario, out to the Atlantic Ocean. But at that point, there's going to be places where water is evaporating somewhere. And as water evaporates, the concentration of those sodium and chloride atoms gets to be too high. You'll learn about this in chemistry with solubility curves. The concentration of them gets too high, and they have to reform crystals. That volume of water there, about 1,000 milliliters, can only handle so many sodium and chlorides in solution. Outside of that, they've got to recrystallize and reform. So those are slightly harder to imagine. Sedimentary rocks, they're chemically formed. They use this term crystalline here, which I really don't like at all, but so it is. If you want to have hints on my crosswords or quizzes that just might happen, Here are the big words. Precipitates. That technically is a precipitate from a solution. That's the fancy pants name for it. Or evaporites. And evaporites, if you can picture the word evaporate in there, that kind of explains that. As water evaporates, you can form the evaporites behind. Rock salt, rock chips, and dolestone are three fairly obvious examples. We should also cover real quick the bioclastic, life formed from carbon and compacted plant remains is going to be what forms coal. I'm going to get way more into that when we talk about Earth's history and the state of the climate and the rock cycle and the carbon cycle and all of that. But for now, if you can picture kind of a swampy area getting preserved and mushing all those dead plants into a big lump of black coal, that's that. All right, so that should do it for sedimentary rocks. Take any other rock. Let's look at it in the rock cycle. Take any other rock. Take a metamorphic rock. Take an igneous rock. Take a sedimentary rock and put it through weathering and erosion. That produces sediments. And as those sediments get deposited and buried and compacted, the cementation thing will take place. And that's generally like, you don't just mush sand into a rock. It takes some mineral cements to really turn it into sandstone. But they're generally already in the water anyway, so it's not really, that's not a giant thing. And you get yourself sedimentary rock. Organized by that table. And I'll probably run at this about the same as the igneous one. I'll give you some work to do with that, then I'll make a quote-unquote rock lab. And we'll move forward. So, happy Monday. Welcome to Earth Science, Canada's greatest stuntman.